dot notation called as the period is used to access the data members of a class. Okay. So here, if I want to access, let's say, the color of a car, I can say object dot color, and I'll access the color. If I want to, let's say, access a method, accelerate, I can say object dot accelerate. Okay, and accelerate is a method that actually helps the car accelerate. Okay, I'm trying to explain it in a way that reflects the real world car. Okay, now here is an example showing how to access class attributes. Okay, so remember, you can only usually you should be able to access class attributes after creating an object of type that class, but that's not compulsory, and we shall see that also in the coming slides, that we can always be able to access certain objects, certain attributes, and even methods without having to create an object. But in this case, we are creating an object. So the class car, still with the attribute engine or field with that value, and there's a method display which simply prints the engine. Okay, so after creating the object, we print this. This is our output. Simple. So constructors, like we said, in most cases, as we shall see, even when we're doing Flutter programming, we usually have classes, and we make sure when you create when you're defining classes, you usually define that you want certain values to always be passed to that class compulsorily. Because sometimes if you don't make it compulsory, people mess up. People always forget to feed certain values into the object and can give us errors. Okay. So a constructor is a special function of the class that is responsible for initializing the variables of the class. Okay. So that defines a constructor with the same name as that of the class. A constructor is a function and hence can be parameterized. Constructors cannot have a return type. Okay. So much as constructor is a function, and usually
People should have followed the instructions. Narrator is doing, people should have followed. You know, when the head goes, it means everything is But from me, the kind of he said his managerial is coming to us. Sometimes our objective is to say that. Bye bye.
it accepts an argument when it prints it. Okay. So when you create a new object of type car, we shall have to pass this value. Remember, you only pass this value if there's a constructor that is parameterized. A parameterized meaning it is expecting a value. Okay. So for this case, it expects a value and it prints it, as you can see. Then we have named constructors. Okay. So sometimes we have to name constructors because you may not be only be passing one value. You might be passing multiple values, and you have to be sure what value you're passing where. Okay. So we name those constructors, we name those values, those arguments. Okay. And also we can have when you're having constructors, you can have more than one constructor in a class. You name them also. You can name them differently. So unlike other programming languages, let's say Java, whereby you can have the same name but just have different number of arguments, here you're given they set you free by giving you the ability to name each constructor differently. Okay. So this is the syntax. Class name dot constructor underscore name in the parameter list. Let's look at an example. If you look at the class car, okay, the first constructor doesn't take in any parameters. So it's a non-parameterized constructor. So here, and constructors are run automatically when you create an object. Okay, they usually create and they usually run automatically when you create an object. But for this case, we are choosing to run specific constructors. Okay, so that is how powerful that programming language also is. Okay? So for the first, when we look at the first one here, car, we just print a string. Then the second one, it is car.nameConst. It takes in a string, a variable named engine. So we print the engine is this. Then another one, another named const. This one takes in a color. This is just to show you that you can give this value called another name. You can give this anything. You can call it anything. Then you pass a value to it. Okay. So this is the output. The engine is this, then the second statement, and the third statement, as we can see in this order that we have not specified. So this keyword in classes is just, it is used to refer to the current class that you're operating in. Okay. So it's the parameter name and the name of the classes fields are the same. So sometimes you don't want to keep using the class name again to refer to certain fields there. So you use this. You're saying, I want to be able to access this car's color. I want to know this car's color. I want to know this car's acceleration speed and all that. Okay. So this keyword here. When we're writing our class, we can say string engine. We give it a default value of empty, and then the constructor string engine. It will, and then when someone passes in the engine value in the constructor, you now say, okay, this new engine value that you've passed in, I want it to be assigned to this class's engine variable. Okay. So that going forward, you can use C1.engine to access this string here. Okay. Yeah. So that's why when you see this this thing being printed, when you run this code, it gives us the output. The engine is this, because you've actually assigned the value you've passed via the constructor to the attribute or field engine, and then you have a print statement. Okay. Then, like we said, getters and setters, very, very important in programming. We use it a lot. And if you're going to be doing mobile programming, which is Flutter, we use getters and setters a lot. And let's just see what they are. They're also called accessors and mutators. Okay? And they allow the program to initialize and retrieve the values of class fields respectively. Okay? So getters or accessors are defined using the get. Setters or mutators are defined using the set keyword. A default getter / setter is associated with every class, and default ones can't be already explicitly defined a setter or getter. The getter has no parameters and returns a value, while the setter has one parameter and does not return a value. So this is the syntax. When you're defining a setter, a getter, you say return type get identifier. So if the getter is supposed to get a value of, let's say, integer, you say int, then you get, then the identifier. Then for the setter, you just say set identifier, and then your implementation. So, class inheritance. Okay. Inheritance is the ability of a program to create new classes from an existing class. In certain instances, you don't have to rewrite certain methods, yet there are other methods that can already help you do such things. All right? Let's say if you want to do animations in Flutter, you don't have to write an animation class with math already exists to come to life. Okay? So it helps you from duplicating code. And sometimes, as programmers, not everyone is as advanced who knows a certain technology really well. And sometimes some people are just new to certain programming languages, or certain tasks we also perform in programming don't have enough time, so you have to borrow existing classes and use them in your code. So that's where inheritance comes in. So here they tell you that the class that is extended to create new classes is called a parent class or superclass. And newly created classes are called the child or subclasses. Okay? So a class inherits from another class using the extends keyword. Child classes inherit all properties and methods except constructors in the parent class. So let's take a look at the practical aspect of this. If we have a class called shape and it has a method called calc area, and the method prints calling calc area defined in the shape class. So here, when we want to inherit this calc area, we want to be able to use this functionality. We just inherit uh, the class shape. So circle inherits from shape using the extends keyword. Okay, when we're using interfaces, we are using implements, but this is extends. Okay, extending meaning we are inheriting. So here we are now see when you create an object or when you instantiate an object of type circle, you use obj dot cal area. Remember when we looked at this operator, this dot, this dot sign here, we say that it's used to access methods and attributes or fields of a class. So here we are now saying obj.cal area. Remember, cal area is not in the circle, but because we inherited from shape, we don't have to define it. We just use the method. Okay. So that's the thing. Same thing we're going to be doing in programming. There are certain classes we're just going to be inheriting. We shall not be writing the things from scratch. Inherit and be able to use its functionality. Okay. For example, let's say if you want to validate an email, let me again use an email example. Okay, you may not necessarily have to write the code from scratch. You just have a method, you just have a class that has the functionalities for validating an email, and then you validate the email. So when you look at types of inheritance, there is single, multiple, and multi-level. So single, whereby every class can at most extend from one parent class. Multiple inheritance. So multiple inheritance is not in that. And for that, a class can inherit from multiple classes. So you can't inherit from multiple classes in that. But we have multi-level inheritance. And we are going to look at that. This is possible in that. So here, this example helps us illustrate single and multi-level, but not multiple inheritance. Okay. So here we say if we have we create a class root, not so, then string a variable called string, then we make it empty. So we create another class called child, and we say extends root. So child is inheriting from root. So root is the parent here in this case of child. So child is a child class. Okay. So this one here represents single level what? Inheritance. If you stop here, that is single level inheritance. But then when you have another class, let's say leaf, and it's again extending a child class, this is now multi-level because the original parent was root, okay, which was inherited by child. But now leaf is also inheriting from child using the extends keyword. So that is multi-level inheritance. Okay. So class inheritance and method overriding. So method overriding is a mechanism by which the child class redefines a method in its parent class. Please excuse me just for 1 minute. I want to take up some call.
One of the things that some yesterday learned was how to do JSON type. So it's something that we can also learn.
Hello. Sorry about that. I had to take that call. Someone was stranded. So we were talking about method overriding. So basically, method overriding is something that we do in programming to be able to change the way certain things happen. For example, if I'm inheriting a certain class and there's a method in it that I don't really like, I override. Okay, I change the way it displays items in a certain way. Okay, so here, if we have a parent class with a method m1, and for it, it takes in it has an argument, it has a parameter, okay, int a, okay, and then it prints the value of a, then it prints that a there. Okay, so when a child inherits the parent, okay, it overrides. Okay, so when you override, you're simply saying ignore the implementation of this parent and only that m1 and the same data type. Okay, so notice that it's the same method name, same return type, and the same data type of the parameter here. Okay, but here we say what we now print inside is like value of b, and then we say b. So when we create an object of type child, okay, when we instantiate and we print, we try to access. So using c.m1, then we pass 12 to it. Okay, we're passing the value 12 to m1. What do you expect us to see? This is it, b. Okay, we have kicked out this method. Okay, so same thing happens with in the real world. Let's say most of us, our computers come with what? Windows, brand new. Okay, but then reach a point whereby, let's say, you want to change the operating system to Linux, so you're overriding, you're removing the default operating system. Okay, yeah. So here we say it prints B. Okay, so what are some of the rules for method overriding? Okay, we looked at some of them, by the way, as we explained in that code snippet up there. So we say the number and type of the function parameters must match while overriding the method. Okay, in case of a mismatch in the number of parameters or their data type, the dat compiler throws an error. For example, if you look at this code, the moment you copy it and paste it, you already have errors, because if the parent has a method m1 that takes it that has a parameter of type int, and it prints out, let's say, value of a is a. Okay, then the child extends the parent, and then for it, it's having a parameter of type string. Okay, the method name is the same but has a parameter of type string. This won't work. Okay, this is not how overriding works. So when you're overriding, you strictly have to keep the parameter type. You have to make sure this type is the same as the one that was in the parent class. Okay, but you can now change whatever is inside here without a problem. So this is one of the rules that they are giving us. Okay, so if you break that simple rule, then your code won't run. Another interesting thing in programming, object-oriented programming in general, is a static keyword. So what is a static keyword? It is something. It's basically a keyword that can be applied to data members of a class. Okay, that means it's fields and methods. Why do we use it? Okay, why do we use it? We use it because at some point we don't want to be able to. We don't want to create objects. Okay, we want to just be able to access certain values of a class without creating objects. For example, if you look at the class static name, okay, so that's just a that's just the name of the class. Then inside it, we have a method static int num equals to 0. That is the keyword static int num. That is a field, okay? So you start with the keyword static, and then definitely the data type, then the identifier, okay, which is num. Then you assign it a value 0. Okay, then we have a method, but this method we don't just put anything in front of it. We put the word static first. You can put static, then maybe a return type can be an integer, it can be a boolean, can be a string in front of it. Then you put the method name there. Okay, then you say, and then the implementation of the method itself. Okay, but now here we can use the method name to access the value we want. Okay, so we say the value of num is static mem.num. So in practice, how do we actually use this class? Okay, so here, unlike in the previous examples where we're creating objects of type a certain class, here we can just use the class name and the dot accessor to be able to get the value, to be able to assign a value to the num variable. So in this case, we are assigning the value 12. Okay, then we also have a method called display inside the static mem class. And because we also it started its method signature by using the static keyword. Okay, so this is what they call a method signature. It's a method signature. Okay, it's a unique signature of a method inside the class. Okay, so the method signature was started by using the keyword static, meaning we can access this method without actually creating an object of type that class. So here we say static mem dot display. So to access this method and run the functionalities that this method is responsible for handling. Let's take a look at the output. The value of num is 12. If we track back quick, we look at this, the default value was 0. Then we assigned a new value 12, and now we're displaying it, and this is what we get. Okay, so that shows us how important the static keyword is. Sometimes you don't want to be able to create objects. Okay, you just want to access the programming. So all these concepts are transferable. Okay, we're going to use it a lot. And then we have this word, the super keyword. So it's a super keyword is a keyword that is it's found in most of the object-oriented programming languages. And why do we use it? We use it to refer to the immediate parent of a class. Okay, so there's reasons why we've put it in the ending parts of the slide. Okay,
You have to
why? First of all, we know that a class can have multi-level parents. Okay, like
that
we
is
looked up there was a class that had two parents. Okay, so it
the fact that
inherited
you
from
said
the
it was
child of a certain parent again.
and the last one
So the super keyword helps us access or refer to the immediate parent. So if I have like two parents on top, okay, let's say parent zero, me, I am what? I am class zero. Okay, I'm the original. Then one is the one that inherits from me. And then two inherits from one. Okay, so if we use super, it will inside three. Three will access what? Two. Okay, the most immediate parent of a class. So the keyword can be used to refer to the superclass version of a variable, property, or method. So super keyword code example. When you look at this code snippet, okay, nothing really changes. We're just trying to mix up multiple concepts now in this example. And all these concepts, we're building up to these concepts starting from the first slide. Okay. Yeah. So we are looking at, let's say, the parent class. We have a field message, and it has a variable. It has the value message variable from the parent class. Then there's also a method called M1. It has a return type of void, and it has a parameter A, which is not a named parameter. Okay. So this is a method. What does this method do? It prints the statement value of A, and then we have the string concatenator that concatenates this value A. Okay. A in this case is an argument. Okay. Here it's a parameter, it becomes an argument. So I'll explain the concept of parameters and arguments in this child class now. Okay. Class child extends parent, then you override. We talked about method overriding. Why do we override methods? Because we want to add certain functionalities that a parent class might not have, or a parent class may be doing something that is not desirable for our program. So we want to trigger tweak it a bit so that it can be able to perform something we want. That's the power of programming, the ability to customize code to do something and solve an exact particular problem that you want. Okay. Yes. So here we override the method m1. Okay. It has an argument. Okay. It has a parameter int p. So at this point we call it a what? A parameter. Why? Because we're just defining the method. Okay. We shall see where we call it what? An argument. So the first statement inside this method that we're overriding is called is print value of b, then we print the value. So we use the super keyword. Okay, remember this slide is about the super keyword. So super, we look for the immediate parent of this class. Okay, so look for the immediate parent and be able to access this method m1. So m1 is this here. Okay, so we pass 13 to it. 13 in this case is called an argument. Okay, when it's up here, it's called a parameter. Here it's called an argument. Why? Because you can put multiple types, but here it dictates that you must pass an integer. So it's an argument. Here it's a parameter. You must pass an integer. So here we already know it's an integer, but of which kind, which number, which integer is that? So this is an argument 13. Okay, so super accesses the method of the parent, immediate parent of a certain class. Remember this class is like it's inheriting from the parent class. Why do we inherit classes? Because we want to be able to use some of the what methods like we have here. And in this special case, we are inheriting it because we even want to override a method. So we have overridden it, and it can now print this statement. It can also access the value, the original what m1 class using super. Okay, yeah, and then we can now print using super the message. Okay, we can print this message. All right. So if we create an object and then we pass our value here, okay, to this object. So this is an argument. We pass an argument here to this method. What do we see? Okay, it will print value of b is 12, this statement over here. Value of a is 13. Remember, this line calls this method. Value of a is 13. Then here, message variable from the parent class. Super.message, we're accessing this and we print it here. So that is how the super keyword is used in that programming. Yeah. So thank you very much for tuning in. That was basically what we wanted to cover today so that we are fully charged for next week's Flutter programming. So next week we shall start off with Flutter programming, and by then hopefully I hope that most of us will embark on installing Flutter. For those of you who have, if you have a computer and you don't really have rights to admin rights, it's going to be hard for you to install the JDK because you actually need admin rights to be able to install that JDK and items such as Git also. Okay, so you need admin rights of a computer. So if you're using like a laboratory computer or laptop and you don't have the admin password, you can ask those people to help you out with the password so that you can be able to install these softwares. Okay, so this is basically, these are the fundamentals of that programming. The rest is stuff that we can see while we're doing Flutter programming, and it will be very practical. I like to make my examples really practical. Yeah, it's pointless to show someone code, okay, but not show them how to use this code in a real world example. That's why I am encouraging that everyone learns how to install these softwares, let's say using the guide in the slides. And I will always be available. You can always inbox me. My number is in the group. You can inbox me and we see if we can if I have some time, I can always connect with you via Google Meet and we see how to install Flutter on your computer. Yeah, if it's possible. So yeah, thank you very much for sparing your time today, and that was it. Yeah, if anyone has some remarks, you can say it here. We're all here to learn. Okay, anyone really? Oh well, so if there is no one with any remarks, Our next meeting is going to be on Monday, and by then you can always take your time to practice that programming. Really become comfortable with it. Programming is not something hard, by the way. It's just if you tune your mind and you say, I can understand this. Trust me, mathematics is way harder than this. Math is way harder than programming. Okay, although we have certain elements of programming, of math in programming, but math is harder than programming. So, and you don't have to be very good at math to be able to do it. As you can see, basic things we're doing are addition and all that stuff. Yeah. So, anyway, thank you very much for tuning today. And with the knowledge we share today, trust me, you won't find it hard in programming Flutter next week. And yeah, so thank you very much for tuning in, and I'd like to call it a good evening and good night to all of you. Bye bye.
Thank you.
Right. Good night.
People should start all those things. That